problem. And this problem is an expected value problem. And we're told that a small software company bids on 2 contracts. It anticipates $60,000 if it gets the larger contract and $30,000 if it gets the smaller contract. The company estimates that there's a 26% chance it will get the larger contract, a 57% chance it will get the smaller contract. And if the company does not get either contract, it will neither gain nor lose money. Assuming the contracts will be awarded independently, what's the expected profit? Okay, so the outcomes here are that they could get neither contract, and in that case, your the random variable would have a value of 0. You get no money. You could get the small contract but lose the large contract. So how would that happen? Or how much money would you get? Well, the small contract is $30,000. The large is $60,000, but they don't get that one. So this would just be $30,000. If they get the large and lose the small, then they would get the $60,000. And if they get both contracts, it would be the $60,000 plus the $30,000, or $90,000. Now we need to figure out the probability of each of these things occurring. And what we'll need to know here is the complement rule. If they know, if 26% chance that they will get the larger contract, then 1 minus 26%, 1 minus 0.26 will be the probability that they don't get the larger contract. Similarly, if there's a 57% chance that they will get the smaller contract, then you can do 1 minus 0.57 to find the probability that they won't get the smaller contract. So getting neither contract, that probability would be not getting the small, which is 1 minus 0.57, times, and then in parentheses, not getting the large, which is 1 minus 0.26. Oops, I didn't type that in quite right there. 1 minus 0.26. So notice I put them in parentheses and I multiplied in between, because 1 minus 0.57 would be the chance of not getting the small, and 1 minus 0.26 would be not getting the large. Multiplying together would mean that you didn't get either one of them. Okay, you get the small, but you lose the large. Okay, so the chance of getting the small is 57%, so that's going to be equal sign 0.57 times now not getting the large, which is going to be 1 minus 0.26 in parentheses. So 0.57 times 1 minus 0.26. And then now get the large but lose the small. So the chances of getting the large is 0.26 times the chance of losing the small is the complement of 0.57. So you'll do parentheses 1 minus 0.57. And then finally, the probability of getting both contracts is equal sign just the 0.26, because that's getting the large, times the 0.57, which is getting the small. You could do 0.57 times 0.26 or 0.26 times 0.57, because commutative property multiplication, either way, you can multiply those and get the same answer. You always want to check to make sure your probability model makes sense. So if we just sum those probabilities, we're looking for 1. We're hoping that it adds to 1, because then we know we will have gotten everything, which it does in fact happen. Now to get the expected value, or the mean, you take the outcome, the numeric outcome, and multiply by its corresponding probability for each of the different outcomes, and then sum that, and that'll be your expected profit, or in this case, expected profit. Okay, so equal sign, you'll take the outcome, so in this case C9, times the probability that it occurs, and hit enter. And then you want to click back up on here, grab your handle, click, and drag down. And finally, your expected profit then is going to be equal sign the sum of those numbers. So 32,700 is what you would expect the profit to be.